Hello statistics folks. I got a new video and a new format that I want to try with you. These are the things that I want you to know so far and the pages that they're found on and what problems you should be practicing. So I'm going to do a real short lesson on expected value now. But before we do that, I want you to look at the last example that we ended our last video with. And we have what we call a probability distribution, where we have all our x's and our x values here, and we have all the probabilities of each one of those things happening. That number 30 is the number of games in a World Series, and this was the percentage of times that the games went 4, 5, 6, 7, or even 8 games. If we remember to multiply these together, the x times the p of x, and then if we add them all together, that would be our average. This is found on page 194. Also, to find the standard deviation, you'd use this formula. If you're using your graphing calculator, you'd put all your x values into list 1 and your p of x's into list 2. You'd subtract 5.8, which is what the average came out to be from each number in L1. So you'd set up an L3, another list, that would be your L1 minus 5.8, square it, don't forget your parentheses, and multiply it by list 2. Then that would give you all the numbers in list 3, which would be this. To add them up, you're going to go second quick to get back to your main screen, which is behind the mode button. You're going to hit second list, this should say, second list. Scroll over to math, go down to number 5, which is the sum. You're going to sum then list 3, which is found behind the number 3. And once you get that number, you need to take the square root, and you could just hit your square root button, which is found on the left side behind the x squared button, and hit second answer. And that will take the square root of the very last number in your screen. Try this one over again, as well as these numbers 29 to 33 on that page. What I want to talk to you next about is expected value. And expected value, let's look at a simple example before we do number 37 and 38, which is the next ones I want to do. Let's say we had a game that we had a boardwalk game, and you have 4 ways that you could win or lose on this boardwalk game. Let's say it costs you $5 to play. This is the cost to play the game. And in this box you win 5. This one maybe you'd win $2. This one, if your wheels, the needle spun and it landed here, you wouldn't win any. And here you'd win $10. Expected value tells you what would happen if you played this game over and over again, repeatedly over a long period of time. So what would happen is, what we would have is we'd have our x's and our p of x's again. And the expected value is actually the sum of the x's times the p of x's. So the things that we want to happen or that could happen and the probability of them happening. Well, what could happen is, since this costs us $5 to play, to win $5 back if you land it in this area, you would actually come out with $0. This one here you're winning 2, but it cost you $5 to play, so you're actually out $3. This one here, it cost you $5 to play, and you're getting nothing back, so you lost your whole $5. And this one here cost you $5 to play, but you won 10, so your net value is a positive $5. Each of these have a 25% chance of happening. So if we multiply these together, which is what the formula says to do, you would get 0 times this would be 0, plus negative 3 times 0.25 is going to be a negative 0.75. 5 times 25 would be 1.25 negative. And this would be a positive 5 times 25, which would be a positive 1.25. Add these up, you could see that these cancel out, And on the average, you would be out 75 cents if you played this game continually over and over again. This is how expected value works. If you had like another game, perhaps you had a wheel like this on the boardwalk, which seems kind of crazy, but you could actually make money off of this wheel. You just a win or lose. If the needle lands on this side, you win, and that side you lose. So let's say you were playing for, I don't know, a little dog, and the dog you want to win for your, this is my dog, believe it or not. If the dog cost you $2.50 to get because you bought them in bulk, and it costs $5 to play this game, what are the things that could happen? You could lose and you can be out your $5, right, if the needle landed on this side. And the probability of that happening would be 50%. You could win, and so you won a $2.50 dog, but it cost you $5 to play. So really, even though you got a prize, you'd be out $2.50, and there's a 50% chance of that happening as well. If you multiplied these down, 5 times 5 is 25 with 1 decimal place. So here it would be a negative 2.5. And here, this times this would come out to be, I think it's $1.25, and you would be out that much money because the 250 times this. So if you added these together, and what you could do is that negative 250 times 0.5 comes out to the minus 25, minus the other 250, where you get $3.75. On the average, every time people came to play your game on the boardwalk, you, as the owner of the booth at the boardwalk, would win $3.75. So you can see what expected value does. Let's look at one last example, which is number 37 in the book. And I want you to try number 38 for homework, and I'll give you the answer to that one. Number 37 in the book, which is on page 200, says this. You're playing roulette, and there's 38 spaces on the roulette wheel. And you win $35. It costs $1 to play. It costs $1 to play. You win $35 if you win. You get your dollar back, the thing says, and then you get $35. What would happen here is, if I win $35, there's a 1 in 38 chance of me winning. The other thing that could happen is I could lose my dollar, and there's a 37 out of 38 chance of winning. You'll have to read the problem and do this one over again. Well, if I add these up, I need to multiply these together. That's what our formula says. So I'm going to get 35 over 38. And then I'm going to get plus negative 37 over 38, which gives me a negative 2 out of 38, which is really what? Negative 1 out of 19. So each time I would play, I think 1 out of 19 comes to, let's see, if we go 1 divided by 19, it comes out to be about 5 cents on the dollar. So you could expect to lose every single time you play 5 cents. Now, people don't normally bet $1 in roulette. They bet $20 or $30 or $100. But on the average, every dollar that's bet, you would lose 5 cents on every dollar that you bet if you played the game over a long period of time. What I want you to do is try number 38. Try 37 over again, which is expected value. And the answer to number 38 comes out to negative 778. Try this one, try the examples in the book, and then we'll come back tomorrow and I'll answer some questions, and our next lesson will be on binomial distributions. Good luck.